Hello everyone. Today we are going to talk about the law of sines and cosine in the area of triangles. We're going to start today talking about a specific case. If we think back to geometry, we proved triangles congruent through a variety of methods. We were able to use side, 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 angle, angle, side, angle, 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 side, and also hypotenuse leg in a right triangle. There was one arrangement of sides relationships, side and angle relationships in two triangles that we couldn't use, and that is side-side angle. So we're going to talk a little bit about why this is the case and what we can do to reconcile that. So here, these two triangles at the top of the page, you'll notice that they actually have quite a bit in common. They have an angle and the two other sides that are identical. Oh, sorry, let me get those sides mapped on as well. This is the scenario of a side-side angle congruence. I would say pretty clearly these two triangles are not the same, but they have a side, and a non-contained angle in common, right? Side, side, non-contained angle. Basically, this is not enough to say that we know everything we need to about this triangle. So we are going to solve triangles throughout the course of this unit. We've done that in some previous lessons. When we solve a triangle, we find all the side lengths and angles that we can. So if I'm given two sides and an angle, a non-contained, I'm going to add that right in here, non-contained angle. There are basically three options. It's possible that based on the information they've given us, that we cannot form a triangle. It's possible we can form one triangle, or we have the ambiguous case and we have two triangles to figure out. If we scroll down here to the table, this is coming directly from our textbook. These are the situations, these relationships between angle A, the side across from it, lowercase a, and the side between the angle A and side A, which we are calling B. You can see here there's quite a few different scenarios. I think this is too much to memorize and to have in our head. I would follow this advice. We should think twice when the side across from the given angle is smaller than the other side. Why would we want to do that? Well, there's one case, if I have an acute angle and a short side A, it's possible that I cannot make a triangle. So that's something I want to be aware of. An additional area where side A is shorter than side B, you can see here. In this case, we have two triangles. We have the ambiguous case. The third case, where side A is smaller than side B, is right next to that one. That happens with an obtuse angle. And if in that case, I have no triangle. So everything is okay in these three cases because we can only form one triangle. In the other cases where A is smaller than side B, we have to be careful. We may have no triangle and we may have multiple triangles. All right, here's what we need to remember. Figured writing it out ahead of time would save us some confusion. So if we are only given the side angle of a triangle, we must solve for both triangles if possible. Understand that there are two angles on the unit circle with identical signs. Sign is positive in Q1 and Q2. In other words, we have angles between 0 and 180 degrees with the same sign. So when we use, say, the law of sines, we want to check the angle that we find and its supplement to see if we potentially have an ambiguous case. We're going to look at an example of each of these in the next few problems. So let's look at example 1. In this case, they tell us that angle A is 75, side A, which is across from angle A, is 51 and side B is 71. This is a red flag here, right? This is a red flag because our side across from the angle is smaller than the other side given. So right now I'm worried that something might go wrong. So I'm going to proceed. I'm going to use the law of sines here. I'm going to set this up. Well, I need to find angle B. So I'm going to set this up as the sine of B over 71 equals the sine of 51 over, excuse me, I made a mistake there, sine of 75 degrees over 51. So I perform my calculation, and I multiply things through, and I get to this point. I get to the point that sine B equals 71 sine of 75 degrees over 51. And what I do, I use the inverse sine. So when I go to my calculator, I find B, and what I end up doing is I try to take the inverse sine of a number that's 1.344. This is a problem. We do not have angles that have sines that are greater than 1 or less than -1. This is an impossible triangle. In other words, this would lead us to an error in our calculator. It would give us a domain error. So this would be a situation where we have no triangle. What happens there, as we try to solve it, it becomes impossible. Our calculator tells us that we've made an error. If that happens, that's how we know that we have no triangle. Let's look at another example. Here they tell us that angle A is 43 degrees, side A is 81, and side B is 62. At this point, I'm feeling a little bit better about things because side A is not shorter than side B. The side across from the known angle is is longer than the side. So let's start finding this. We're going to use the law of sines. I prefer to put my unknown value in the top left of my ratio. It doesn't really make a huge difference because we end up multiplying things through. I'll have the sine of 43 over 81. What can go wrong here? Not too much. Make sure that your calculator is in degree mode. We are going to be bouncing back and forth between degree and radian mode often, so make sure you're taking the time to make sure you're in the proper mode. So I'm just simplifying things. I'm going to take the inverse sine of both sides to find angle B, and what my calculator tells me is that angle B is going to be 31.46 degrees. But I have only been given side-side angle, so I'm also going to check its supplement. B could potentially be 180 minus 31.46 or 148.54 degrees. So what I need to do is check to see, is this other triangle possible? So what I want to do is compare angles A and B and try to see if I have any degrees left for a third angle in my triangle. Well, if I were to add 148 and 43, I have 190 something degrees. I think it's 191 and change. Well, that's too many degrees. I can't allow for this other angle to exist because we wouldn't have a possible triangle. So in this case, we only have one. So we're going to go ahead and solve for all the other pieces. If I have two angles, I can find the third. So one angle is 31.46. Angle A was 43. So angle C is going to be 105.54 degrees. So we have all three of our angles. We have angle A in the problem, angle B we found using our law of sines, and angle C using our triangle sum theorem, right, adding all three angles up to 180. The last piece here I'm going to finish up is going to be finding side length C. And again, I'm going to use the law of sines. So I'm going to say C over the sine of 105.54 equals, well, I like to use the original problem just because there's less room for error. You know, if I made a mistake finding B, it might carry it over into finding C. But if I use the information from the original problem, it's a little bit more foolproof. So I will find that C equals 81 times the sine of 105.54 divided by the sine of 43. I can plug that exactly as I see it into my calculator, and I'll find that C equals 114.43. So we found all three sides and we found all three angles. We are done. We checked for the ambiguous case. It was not showing up in this case. Last case, you could probably guess what's going to happen here. We have seen with no triangle possible. We've seen one triangle possible. Let's go ahead and see what happens here. So they give us side C and angle C, as well as side B. Again, red flag time. Why is it a red flag? The side across from the angle is smaller than the other side given. So in the back of my head, I'm thinking ambiguous case is possible. Impossible triangle is also an option here. I'm going to proceed with that in the back of my head. So I'm going to start here by trying to find angle B. So I'm going to say the sine of angle B divided by 46 will equal the sine of 31 degrees over 29. So I'm going through this problem now, and I'm going to solve for angle B. So when I do this, I'm going to get the sine of B equals 46 times the sine of 31 divided by 29. I will find that angle B, using the inverse sine in my calculator, is 54.78 degrees, or its supplement, right? Subtract that same value from 180, 125.22 degrees. So now I'm going to just verify that this angle could fit into my triangle. So I have 125 and 31. If I were to add them together, I get 156 and change. That's definitely less than 180. What does that mean? We have the ambiguous case. So we need to solve both triangles. So I think it's important to organize yourself, right? In triangle 1, we'll keep that on the left, and triangle 2, we'll keep our work on the right. We'll use this area at the bottom of our screen as kind of our final answer. The first thing we should do is figure out angle A for both triangles. We have angle C, we have angle B. Let's find angle C in both cases. So if angle C is 31 degrees and angle B is 54 degrees, angle A on the left-hand side, right, these are angles, angle A is going to be relatively large. We can subtract 54.78 and 31 from 180, and what we will find is that angle A is 94.22 degrees in triangle 1. In our other triangle, angle A would equal, well, in this case, we would take 125 plus 31, subtract that quantity from 180, and we would find that angle A would be 23.78 degrees. So we found all three angles in both triangles now, and now we have to finish both of them, and we're going to do that by finding, finally, side, let's see, what are we missing? Side A, I believe. Yeah, we were given B and C. Our remaining side is little a. And in both cases, on both triangle 1 and triangle 2, we're going to have to use our law of sines. So A over the sine of 94.22 will be set equal to 29 over the sine of 31. And through some algebraic manipulation and my calculator, I find that side A equals 56.15. I'm going to do the same operation over here. I'll just use a different color with triangle 2. In this case, A is going to be divided by the sine of 23.78. And that will also be set equal to 29 over the sine of 31. In this triangle, side A will equal, let's see, 22.704. So side A is 22.71. So when we have the ambiguous case, this is the most work we'll have to do. We have to solve two separate triangles. We're going to get two answers for angle B, two answers for angle A, and two answers for side A. I think this is a reasonable place to stop. Part 1, we're going to move on to area in our next video. Thanks.